Hi, today we're going to be learning about solving problems involving angles at a point and parallel lines. First, let's take a look at angles at a point. When you have angles around a point, the sum of the angles must be 360 degrees. So if you have this example over here, all of the angles around point O will add up to 360 degrees, and our reason is going to be angles around a point. When you've got angles on a straight line, then all of the angles on the straight line at a particular point must add up to 180 degrees. So here I've got A1, A2, A3, and A4. All of those angles must add up to 180 degrees, and our reason will be angles on a straight line. Then, when you have angles that are formed by straight lines intersecting with each other, we end up with what we call vertically opposite angles. Angles that are vertically opposite to each other will be equal to each other. So in this example over here, angle O1 and O4, those two angles are equal. Angle O2 and O5, these two angles over here are equal. And angle O3 and O6, these two angles over here are equal. And the reason we can say that for each of them is because they are vertically opposite angles, and vertically opposite angles are equal. Then let's have a look at parallel lines which are being cut by a transversal. Now remember, parallel lines are lines that are always going to be the same distance apart. They never get closer and they never get further apart from each other. They stay the same distance. And they're special. When you have a line that cuts through parallel lines like this, we call it a transversal. When we have a transversal cutting through parallel lines, they form special angles that are related to each other because of these lines being parallel. So in this case, we're looking at corresponding angles. Corresponding angles are angles that are in the same position to each other relative to the parallel lines. So angle G1 and H1, you'll see over here, they're both on the left of the transversal and they're both sitting on top of the parallel lines. They are corresponding. Angle G2 and H2 are both on the right of the transversal and they're also both sitting on top of the parallel lines. Angle G3 and H3, they are both on the right of the transversal and they are sitting underneath the parallel lines. And G4 and H4 are both on the left of the transversal and they're also both sitting underneath the parallel lines. So they're in the same positions as each other. G1 and H1 are in the same positions as each other relative to the parallel lines and the transversal. Corresponding angles will be equal to each other when the lines that the transversal is cutting through are parallel. Okay, so in this case over here, G1 and H1 are equal, G2 and H2 are equal, G3 and H3 are equal, and G4 and H4 are equal. And the reason is because they are corresponding angles with AB parallel to CD. Now remember, corresponding angles are only equal when the lines are parallel. If the lines are not parallel, then the corresponding angles will not be equal to each other. Next, we've got our co-interior angles. Co means together, interior means inside. So co-interior angles are angles that are together inside the same space. So I've got over here, this angle over here, G4 and H1, they are inside the same space. They are co-interior. And over here, I've got G3 and H2. They are together inside the same space. They are co-interior. Co-interior angles are what we call supplementary. That means that they add up to 180 degrees. They're not equal to each other, they are supplementary. So in this case over here, I've got G3 and H2. If I add them up, I will get 180 degrees. My reason is because they are co-interior angles with AB parallel to CD. And G4 and H1 will also add up to 180 degrees for the same reason. Once again, this is only true because those lines are parallel. If the lines are not parallel, then the co-interior angles will not be supplementary to each other. Then we've got alternate angles. Alternate angles are angles that are going to be on different sides of the transversal. So G3 and H1, you'll see over here I've got G3 and H1. They are on opposite sides of the transversal and they are both between the parallel lines. Then over here I've got G4 and H2 are also on opposite sides of the transversal and they're both between the parallel lines. These are what we call alternate angles, and alternate angles will be equal to each other. these are alternate interior, although you don't have to specify that they're interior. You can just say alternate angles. The angles that are outside the parallel lines can also be alternate. So G1 and H3 are also alternate, but they are what we call alternate exterior angles because they are outside the parallel lines, and exterior means outside. So G1 and H3 are alternate exterior angles, and then G2 and H4 are also alternate exterior angles. Alternate angles will be equal to each other when the lines are parallel. So because AB is parallel to CD, the alternate angles G3 and H1 are equal. The alternate angles G4 and H2 are equal. The alternate exterior angles G1 and H3 are equal. And the alternate exterior angles G2 and H4 are also equal. Okay, this is just to help you to remember the different types of angles we get with parallel lines. So here we've got an F, which is made by corresponding angles. Remember, corresponding angles are in the same position as each other relative to the parallel lines. They will both be on the same side of the transversal. So if this is your transversal over here, they're on the same side of the transversal, and they are both on the same sides of the parallel lines. So in this case, they're both sitting underneath the parallel lines. Co-interior angles make the U shape. You've got your parallel lines over here, and you've got your transversal. The co-interior angles will both be between the parallel lines, and they will be on the same side of the transversal. They'll be inside the same space, and they are supplementary. They add up to 180. Corresponding angles are equal. Co-interior angles are supplementary. And then alternate angles are angles that are on different sides. They're on opposite sides of the transversal. So if these are our parallel lines over here, and this is our transversal, then these two angles are on opposite sides of the transversal, and they will both be between the parallel lines, or if you have alternate exterior angles, they will both be outside the parallel lines. And alternate angles will be equal to each other. Okay, so now let's go and have a look at some examples where we're going to be solving problems using angles at a point and angles where we have parallel lines that are being cut by a transversal. Here's our first example. In this example, we've got AB, which is parallel to CE. We've got BC, which is parallel to AD. They've told us that BD is equal to AD. They've told us that angle A is 35 degrees, and we need to work out the sizes of X, Y, and Z. Okay, so let's go and have a look at how we would solve this problem. Okay, so here I've got my diagram. Now, before we start, let me just remind you that when you're working with geometry, for every statement that you make, you always have to give a reason. Okay, so first we're going to try and work out what X is. So X is sitting over here. The only angle where I know the size at the moment is angle A, which is 35 degrees. Okay, so I know that this is 35. I need to work out what X is. So I need to see how I can relate that to X. So if you look over here, if I see what shape, because if you see this is a parallel line to that. So I've got two parallel lines. The shape that this makes over here is a Z shape or an N shape. Okay, so that's like the N in the word fun. So those are alternate angles. They are on opposite sides of the transversal, and they're both between the parallel lines. So these are alternate, which means that they are equal to each other. So I can say that X is 35 degrees. Okay, and the reason I can say that is because these are alternate angles with AB parallel to CE. You always have to say which lines are parallel when you are working with alternate, corresponding, or co-interior angles. Otherwise, you can't say that they are equal or supplementary. Okay, so now that I've said that, I can go and fill it in on my diagram. So this is 35 degrees over here. Right, next I need to work out what Z is. Now Z is sitting over here. And I have now got the size of A, which is 35. I've also got X, which is 35. Now A is a little bit far to use to help me to work out what Y is, but X I can. If you look over here, this is parallel to that. And here I've got a transversal that's cutting through, and I've got angle Y and angle X over there. This is kind of like that F shape in the word fun. So these are corresponding angles. Y and 35 are both on the same side of the transversal. They're both on the right hand side of the transversal if we look at it like this. And they're both underneath the parallel lines if we look at it like that over there. So they are both in the same position as each other relative to the transversal and the parallel lines. So they are corresponding angles, which means that they are going to be equal to each other. So I can say that Y is also 35 degrees. And my reason for that is because they are corresponding angles. With BC parallel to AD. Okay, so now that I've got that, I can fill it in on my diagram. So this is 35 degrees over here. Right, now I need to work out what Z is. Okay, so to work out Z, I can't really do it straight away as I've got it over here. I can't do it in just one step. I'm going to have to do more than one step here. So what I'm going to do to work out Z is, first of all, if you look over here, Z is part of this angle. Okay, so I could work with co-interior angles with Z and B1 and Y over here, or Z and B1 and angle A over here. Okay, so those are co-interior, which means that they're supplementary, or these are co-interior, which means that they're supplementary. Either way, it'll give me the same result, but I have to know what B1 is first to be able to do that. So let's go and work out what B1 is. Now, if you look at B1, it is inside this triangle where they've told us that this is equal to that. So I've got a triangle with equal sides, two sides that are equal. That means it's an isosceles triangle. So the angles that are opposite those equal sides will be equal to each other. So angle B1 is opposite an equal side, and the other equal side is opposite this angle over here, angle A, which is 35 degrees. So angle B1 is going to be 35 degrees because they will be equal to each other because they're opposite the equal sides. So angle B1 is equal to 35 degrees. And my reason is because they are angles opposite equal sides. In triangle ABD. Okay, so now I know that this is 35 degrees over here. Okay, once I know that, I can use that to help me to work out Z. So this whole angle is going to be co-interior with this or with that. It doesn't really matter which one you use, but it's co-interior, which means that these angles are going to be supplementary. Okay, so now I can say that Z plus 35 degrees plus this 35 degrees over here must equal 180 degrees, or Z plus 35 plus this 35 must equal 180 degrees. Doesn't matter which one it is because both of these sets of lines are parallel to each other. Okay, so the reason I can say that they are supplementary, the reason I can say that they add up to 180 is because they are co-interior angles with BC parallel to AD, or I could have said with AB parallel to CE. Either way, it would work. Okay, so now we can go and solve for Z. So Z is equal to 180 minus 35 minus 35, that's 110 degrees. So that's what we should get for Z. So X was 35 degrees, Y was 35 degrees, and Z is 110 degrees. Okay, now you're going to do some for yourself. Here's the first one you're going to do. For question A, you've been told that AB is parallel to CE. You've been told that angle A is 25 degrees. Angle EDO is 125 degrees. And you need to work out X, Y, and Z. I'm going to give you 2 minutes for this question. Okay, so let's go through that question and see what you should have got. Right, so over here I've got my diagram. So first of all, we have to work out what x is. So if you look over here, I've got two angles that I've been told the size of. I've been told that A is 25 degrees and that angle EDO is 125 degrees. Now, this one over here isn't going to help me to work out x. It could help me if I knew what this angle was and I was able to use the exterior angle of the triangle, but I don't know what that angle is. I'm still going to work it out later. So I'm not going to be able to use the 125. What I can do is I can use the 25 degrees. Because these lines are parallel, if you look over here, this forms that Z or N sort of shape, which means that these are alternate angles. They are on opposite sides of the transversal, and they're both between the parallel lines. So they're alternate, which means that they are equal. So x is equal to 25 degrees. And the reason I can say that is because they are alternate angles with AB parallel to CE. Okay, so now I can go and fill that in over here, that x is 25 degrees. Right, next I'm going to go and work out what y is. Now, like I said, if I had known what y was, I could have used the 125 with y to work out what x is using the exterior angle of the triangle, but I didn't. But now I can do that the other way around. I now know what x is. I have this 125. I can use the exterior angle of this triangle to work out what y is. Remember, the exterior angle of the triangle is equal to the sum of the opposite interior angles. So this angle is equal to that plus that. So if this is 125 degrees and this is 25, I can say 125 minus 25 will give me y. So y is going to be 100 degrees. And the reason I can say that is because of the exterior angle of triangle CDO. Okay, so now I know that this angle over here is 100 degrees. Right. Once I've got angle Y, I can then work out angle Z, which is directly opposite angle Y across the point where these two lines intersect. And they're straight lines intersecting, which means I now have vertically opposite angles. Remember, vertically opposite angles are equal to each other. So Z is going to be 100 degrees as well. So I can say, therefore, Z is equal to 100 degrees. And my reason is going to be because vertically opposite angles are equal to each other. So I now know that Z is 100 degrees. So in this example, you should have got that X is 25, Y is 100, and Z is also 100. Okay, let's go on to question B. In question B, you've been told that AB, CE, and FG are all parallel to each other. You've been given angle A is 36 degrees, angle B is 111 degrees, and you need to work out the sizes of X, Y, and Z. I'm going to give you 2 minutes for this question as well. Okay, so let's go through that example and see what you should have got. Right, so first of all, we have to work out what x is. Now, I have two angles that I've been told the size of. I've been told this angle is 36 and this angle is 111. Now, this one isn't going to help me at all for working out x, because even though these are parallel lines, this angle is here by this transversal and x is by this transversal. They're at different transversals, which means that they can't help each other. Okay, so they're not related. But this angle over here, the 36, is related to the x because they both are by the same transversal, and I've got these parallel lines over here. So if you look at the shape that this is making, over here I've got this angle and this angle. They are kind of making this F shape. It's a bit of a skew F, but it's a bit of an F anyway. And that means that they are corresponding. They're both on the same side of the transversal, and they're both underneath the parallel lines. They're in the same positions as each other relative to the parallel lines and the transversal. So they are equal to each other. So X is equal to 36 degrees. And my reason for that is because they are corresponding angles with AB parallel to CE. Okay, so now I know that this is 36 degrees over here. Okay, now we're going to go and work out what Y is. Now if you look at Y, it's on the other side of that same transversal. It looks kind of like it's a little bit close to this transversal over here, but be careful, Y is not right next to this line over here. Okay, so it's not going to be related to the 111. It is related to the 36 there or the 36 here because it's sitting next to that same transversal. Okay, so over here I'm looking either at this 36 or that 36. It doesn't matter which one you're working with because they're the same. And if you look at the shape made by the Y and either of those two 36s, so I can work with that one over there, or I can work with this one over here, it kind of makes that N sort of shape, okay, or the Z shape. So they are alternate angles. They are on opposite sides of the transversal between the parallel lines. So I can say that Y is 36 degrees because alternate angles are equal to each other. So Y is 36 degrees, and my reason is because of alternate angles with, I'm using over here CE parallel to FG. But you could also say AB parallel to FG, because if you're working with Y alternate to A, then the lines that you're working with that are parallel are AB and FG. So it doesn't matter, as long as you have FG as one of your parallel lines. It could have been AB and FG, or it could have been CE and FG. Okay, so that's to work out Y. So now I know that Y is also 36 degrees over here. Right, now we're going to go and work out what Z is. Now Z is different to X and Y because Z is sitting next to the other transversal. So this line over here that's cutting through the parallel lines. Okay, so this one has to be related to the 111, which is also sitting next to that same transversal over there. So these two are now going to be related to each other. Now if you look at the shape that they make, over here I've got a parallel line and the parallel line and the transversal. These are making, if you turn it like that, it's kind of like that U shape, okay, in the word fun. So they are co-interior. These two angles are together inside the same space. Now remember, co-interior angles, when your lines are parallel, are going to be supplementary. That means that these two angles must add up to 180 degrees. So I can say that 180 minus 111 will give me Z. So that means that Z is going to be 69 degrees. So Z is 69 degrees. And my reason is because these two angles are co-interior and these lines are parallel. And we know that when lines are parallel, co-interior angles will be supplementary, and that's how we got that 69 over there. So that's what you should have got for question B. Right, let's go on to question C. In question C, you've got AB parallel to CD, and you've been told that AD is equal to AB and also equal to AC. And you've been told that angle DAC is 124 degrees, and you need to work out the size of X, Y, and Z. I'm going to give you 4 minutes for this question. Okay, so let's go through that question and see what you should have got. Right, so first of all, over here we have to work out what X is. The only angle that we've been told the size of is this angle over here, which is 124 degrees. Now to work out X, it is in the same triangle as that 124 degrees. So I'm going to work with the fact that this side and that side of the triangle, they told me, are equal to each other, which means that this is an isosceles triangle. So X and angle D are both opposite the equal sides, which means that they're going to be equal to each other. So I can say that angle D is equal to X. And the reason I can say that is because they are angles opposite equal sides. In triangle ACD. Okay, so now I know that this over here is X, which means that I can now work out what X is because these angles are inside the triangle. So I can use the sum of the angles of the triangle. So I can say that X is equal to 180 minus 124 to get what is left over for these two, and then I divide by 2 to find out what one of them is. So it's 180 minus 124, all divided by 2. And the reason I can say that is because of the sum of the angles in triangle ACD. Okay, so now I can go and work that out. So 180 minus 124 gives me 56, and then I divide that by 2 to get 1x, and that's 28 degrees. So x is going to be 28 degrees over here. And this one over here as well. Okay, so now I know what x is. Now we're going to go and work out what y is. Now y, if you look over here, I've got a parallel line with this line over here, and these angles, if you see what shape this makes, they are on opposite sides of the transversal, where AC is the transversal. They're on opposite sides, and they're both between the parallel lines, and it forms this N sort of shape, like that. So that is the N in our word fun, which is the alternate angles. And remember, we know that when the lines are parallel, alternate angles will be equal to each other. So that means that y is going to be equal to x, which is 28 degrees. So y is 28 degrees as well. And the reason I can say that is because they are alternate angles with AB parallel to CD. Okay, so now I know over here that this is 28 degrees. Now I need to go and work out what Z is. Now Z is in the same triangle as Y over here, which we just worked out. And we've been told in that triangle that AB is equal to AC. So I'm going to do basically the same thing as I did over here. First, I'm going to say that angle C1 is equal to angle B because they are both opposite those equal angles, or those equal sides. So I can say that angle C1 is equal to Z because they are angles opposite equal sides. In triangle ABC. Okay, so then this is Z over here, like that. Now that I know I've got two Z's and at 28 degrees, I can work out what Z is by using the interior angles of that triangle. So I can say that Z is equal to 180 minus 28 and then divided by 2, because 2Z is 180 minus 28. Now I have to divide by 2 to get what 1Z is. So 180 minus 28, that gives me 152, and then I divide that by 2 and it gives me 76. So now I know that Z is 76 degrees. And the reason that I could say this is because of the sum of the angles in triangle ABC. Remember, for every statement that you make, you have to give a reason. So that's what you should have got for question C, that X is 28 over here, Y is 28, and Z is 76. Okay, now we're going to go on to the last one for today, which is question D. In question D, you've got AB parallel to FC. You've also got AD parallel to FE, and you've been told that CG and CD are equal to each other, and you've been given the size of angle B is 112, and you need to work out A, B, C, D, E, F, and G. So you have quite a few angles to work out here. Okay, so I'm going to give you 5 minutes for this question. Okay, let's go through that question and see what you should have got. The first angle we need to work out is A over here. Now, the only angle that we've actually been told the size of is angle B, which is 112 degrees. So we have to see how we can work out A using 112 degrees over here. So if you look at how they are related to each other, they're between parallel lines over there, and they're both on the same side of the transversal. They're in the same space. So these are what we call co-interior angles, and they are going to be supplementary to each other because those lines are parallel. So I can say that A is equal to 180 minus 112, which gives me 68 degrees. And the reason I can say that is because these two angles are co-interior with AB parallel to FC. And we know that when lines are parallel, co-interior angles will be supplementary, so they're going to add up to 180 degrees. Okay, so now that I've got that, I can go and fill it in over here. So this is 68 degrees. Right, the next thing we're going to do is work out B. Now you've got two options for working out B. You can either use angles on a straight line, or you can use corresponding angles with this 112, because these lines are parallel, and B and 112 are both sitting on the same side of the transversal, and they're both on the right hand side of the parallel line. So they're in the same position as each other with respect to the parallel lines and the transversal. So B is equal to 112 degrees, and you can use corresponding angles with those parallel lines as your reason, or you can use angles on a straight line. It doesn't matter which way you did it. Okay, so now I know that this is 112 over here as well. Right, next we need to work out what C is. Now C is sitting inside this triangle over here. We've got this angle, which is 112. We don't know what that angle is, but we have been told that these two lines are equal to each other. GC and CD are equal, which means that this is an isosceles triangle. Now we know that the angles opposite the equal sides will be equal. So that means that angle G1 will also be equal to C because they are both opposite the equal sides. So I can say angle G1 is equal to C because of angles opposite equal sides in triangle CDG. Okay, and because this is C over there, I can now use the interior angles of that triangle, or I can use the exterior angle of the triangle because I know what this angle over here is. It is 68 degrees because I already worked that out. So I'm going to use the exterior angle of the triangle. Remember, the exterior angle of a triangle is equal to the sum of the opposite interior angles. So C plus C will equal 68 degrees. Okay, so 2C is equal to 68 degrees. And the reason I can say that is because of the exterior angle of triangle CDG. But remember, you could also have used the sum of the angles inside that triangle. So 112 plus C would give you 180. Okay, and now I'm going to go and work out what C is by dividing by 2. So therefore C is equal to 34 degrees. So both of these angles over here will be 34 degrees. Now that we've worked out what C is, we're going to go and do D. So D is sitting over here. I've got, again, a couple of options. I can use angles on a straight line to work out D, or D is the exterior angle of this triangle where these are the opposite interior angles. So I can also use the exterior angle of the triangle to work out D as well. It's up to you which method you want to use. I'm going to use angles on a straight line. So I'm going to say D is equal to, it's 180 minus 34. So 180 minus 34, that gives me 146 degrees. So that is because of angles on a straight line. Okay, so now I can go and put that in over here. 146 degrees. Now the easiest and quickest way to work out E is to use vertically opposite angles, because I've got a straight line crossing over another straight line, so the angles directly opposite each other will be equal. So E is going to be 146 degrees. And my reason is vertically opposite angles are equal. Okay, so now I know that this is also 146 degrees over here. Right. Next, I'm going to work out F. Now, F is over here. Now, I have got, again, a few options for working out F. I can use the angles inside this big triangle, ABD. I've got that one. I've got that one, so I can just work out F using the sum of the angles. Or F is sitting between this line and that line, which are parallel. And here I've got a transversal cutting through those parallel lines. So F and E, which is 146, which we already worked out, are co-interior, so they are supplementary. F is also corresponding to this angle G1 over here, which we worked out was 34 degrees. Now, corresponding is easier to do than co-interior because we don't have to work anything out for it because they're equal to each other. So I'm going to use corresponding angles over here. So I'm going to say that these angles are corresponding. So I've got my parallel lines over there and my transversal. And these angles are corresponding because they are both on the same side of the transversal as each other. And they are both sitting underneath those parallel lines if I have it sitting like that. So it's kind of like a backwards F. So they are corresponding, which means that they are equal to each other because those lines are parallel. So F is equal to 34 degrees. And the reason I can say that is because they are corresponding angles with AB parallel to FC. Okay, so now I know that this over here is 34 degrees. And then the last one that we need to work out is G, which is sitting over here. Now G, again, I've got a couple of options. I can work with co-interior or corresponding angles for G. If you look where G is, it is sitting between this line and that line over here. This line is parallel to that one, so I can work with this as my transversal, where G is on the right hand side of that transversal. If you look over here, angle G1 over here, which we worked out was 34 degrees, is also on the right hand side of the transversal, and they're both sitting underneath the parallel lines. So over here I've got an F shape. If you look at that over there, that angle and that angle, they are in the same position as each other with respect to the parallel lines and the transversal. They're both on the same side of the transversal and they're both sitting underneath the parallel lines. So they're going to be corresponding, which means that they're going to be equal because those lines are parallel. So now I can say that G is equal to 34 degrees as well. And my reason here is also corresponding angles. But this time, the parallel lines that I'm looking at are FE and AD. Okay, and that is what you should have got for that question. So A is 68 degrees, B is 112 degrees, C is 34 degrees, D is 146, E is also 146, F is 34 degrees, and G is also 34 degrees. And that's how we solve problems involving angles at a point and parallel lines. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.